Hi, everyone, and thanks for coming to watch our GTC talk this year at GTC 2023. Today, we're going to be talking about streaming XR at global scale. Uh, what we're going to be talking about today, we're going to start with a little bit of a background, who we are and our background in this problem space as it relates to remote streaming. We're going to talk about some of the lessons we've learned in the process of building out a platform to support flat streaming, and we'll define what that is as we move along. We're going to show a demo that includes basically an example of how we built a platform to support Cloud XR streaming at scale. And then we're going to dive into what the architecture actually looks like to support that, both at a global scale and at a much more smaller regional scale. And then we're going to spend some time just talking about future-facing work and where we're going to be going from here. And as with all GTC talks, there's going to be Q&A, so please feel free to put your questions into the Q&A, and we'll be answering them as we go. So before we get started, my name is Chris Jarabek. I am the head of product development at PureWeb. So that means I oversee all of the engineering and product management related functions at the company. And I'm really focused on sort of the near to medium term decisions about what we're going to be building within our product. And that's taking into account customer requirements, market requirements, and really chiefly some of the inputs that I get from my colleague, Kevin.
Thanks, Chris. Hi, everyone. My name's Kevin Viggers. I'm the head of R&D here at PureWeb. I work really closely with Chris, a little bit further out from where he's looking at. In R&D, we look at interesting ideas that are coming down the pipe, things that might be disruptive to our product line or to the industry in general, and take some time and research and prototype around those ideas.
So what is PureWeb Reality? So PureWeb Reality is a platform that we've built stemming from our 15-year experience building remote streaming applications. It's a fully managed distribution platform for remote streaming applications. And we focus in on what we consider to be flat streaming applications. So this will be something like an Unreal Engine pixel streaming application or a rendered streaming application from the Unity engine, where you have a stream source that's running on a remote server somewhere, and you're using a network protocol like WebRTC to stream interactive 3D data to a browser as an end device. And doing this at small scale is generally fairly straightforward. The problem is when you want to do this at large scale. And so this is where we have been really focusing on solving the problem of how you manage all the edge infrastructure orchestration, security, the distribution of running these remote flat streaming experiences at really large scale. And we're not particularly vertically aligned in terms of how we look at the market in terms of the use cases we serve, because we're really more builder aligned. And so we see use cases coming from all across the market space. We see a lot of use cases coming from architecture, engineering, construction. Training and simulation is quite large, and digital twins is one of our larger use cases. And all of these have this theme in common where you typically have either very visually intense data, or you'll have data that has, or applications that have heavy data requirements that make it infeasible to move that data around. And in all of these cases, you're dealing with content where you would normally run this on a local machine that has an NVIDIA GPU in it, but this is not really feasible in the enterprise. It's not really feasible to put a gaming grade desktop on everybody's workstation. And so this is where remote streaming comes in. It allows you to run these graphically intensive applications from a remote location and then put them into somebody's web browser without the need for the hardware requirements locally. So why are we looking at VR now? Well, historically, VR was something of a hobbyist focus. It was for gamers who wanted to do, entertainment as games type of experiences on their local desktops to tethered headset displays. That really was the driving force in adoption for VR for the last several years. And what we're seeing is something, an inflection point in the market, where in the last few years in particular, you're seeing a fairly significant uptick in large enterprises looking at what can be done with this technology. They're looking to improve training outcomes. They're looking to improve decision making around large graphical data sets and improve collaboration. But many of the same challenges that we've looked to solve in the flat streaming space also exist in the VR space in terms of the requirement for having large GPU desktop grade hardware sitting next to the end user, which really isn't feasible. And there are a number of other barriers to entry, which Kevin is going to speak to.
Thanks, Chris. Today, people entering the VR space are really faced with two distinct ends of the spectrum when it comes to building out VR experiences. One where they adopt an untethered headset, which offers a lower level of detail and less options in terms of the amount of data and interaction they can create, or a tethered headset experience, which comes with higher fidelity, rich data options, but is bound to the workstation and some enterprise constraints. So when we look at enterprise scenarios like simulation, training, digital twins, that is where that tethered experience has predominantly been. But that whole environment requires a costly investment, IT support, and maintenance that is sometimes just infeasible. With CloudXR, NVIDIA has offered a feasible third option, which is to remotely stream high fidelity, rich VR experiences to untethered headsets. Now, what they put together is something that we refer to as streaming in the small, where an individual application can be made available to an individual user in a manual sort of way, and to do so is quite straightforward. They can experience the remote stream, but the experience of putting that together is largely individual and manual. What we're interested in at PureWeb is scalability, taking these kinds of experiences and bringing multiple CloudXR applications to the world in a dynamic way where audiences, thousands of users can simultaneously consume and experience these VR experiences around the world.
Thanks a lot, Kevin. So, given our history in working on building out this platform to support flat streaming for the last 5 years, we saw some really obvious parallels in the problem space and the overlap of the problems that needed to be solved in order to do CloudXR at scale. Some of these things specifically, you're looking at needing to maximize the total number of GPUs that you have and maximizing the distribution of those GPUs so that you can minimize the network effects of latency, because that network effect becomes so much more important when you're in a headset where even a little bit of latency can result in literal nausea for the end user. So making sure that you minimize that latency is so key, even more so than it is in a flat streaming application. Additionally, you're going to need end-to-end provisioning pipelines so that you can get your application from where it needs to be on your local desktop out to thousands of servers around the world for optimal consumption from your end users. And then lastly, you're going to need both a smart routing system to make sure that users who come into the platform get sent to the optimal server for them, and the matchmaking to make sure that they're minimizing round trip latency, and then to make sure that you're not waiting a long time to get that session, optimally less than sort of 10 to 15 seconds. And then end device SDKs, because you have to remember that the stream source is running over on a server somewhere in a cloud, and the client is not talking to the stream source directly, but rather it's talking through a client device of some sort, of client application of some sort, which is going to be built around some sort of SDK. So you're going to need an SDK to build that client experience. So what we're going to show next is a demo of basically running a CloudXR on the PureWeb Reality platform. And Kevin's going to talk through all of this. But the key piece here to really drive home is that this video hasn't been edited down for length. So we're going to see an upload, provisioning, deployment, and streaming experience end to end in about 3 minutes. And there's no smoke and mirrors here. Kevin, do you want to kick us off?
Yeah, great. Thanks, Chris. Let's get started. So in this video, you'll see really two distinct activities. One, uploading the OpenXR, CloudXR-based model to our PureWeb console. And then second to that, we're going to look at the consuming of that model, the experience around that. So right now, I'm just locating an Unreal 5 VR template file here and uploading it to the platform, just providing a few runtime configurations so that this application can run appropriately. The model itself is quite small. It's about 400 megabytes. It doesn't take long to upload into the platform. Our platform acts as a single source of truth for applications that are being uploaded. It gives us a central way to manage them. But as you can see, once the upload is done, the platform kicks into action and begins to distribute that model out to the various virtualization providers around the world. It doesn't take long before a virtualization provider checks in here. It probably is going to happen in just a few seconds here. You'll see that unavailable turn to green. And now I'm able to hop over to the headset. In this case, I've got a MetaQuest 2, and it just takes a moment for me to grab that headset. And once it's on, I'm going to locate the CloudXR client that we built to demonstrate this. This client is just a standard CloudXR client, but what we've done is we've had it open up a web view at start. This web view is just loading that console experience again. And I'm scrolling down, and there's the model I've just uploaded. We built in a preview experience into this console, and it's entirely web-based preview client here. And once this is up, it is just a matter of clicking that play button, which creates a launch request to our platform and begins the process of locating and negotiating a connection between the instance somewhere out there in a virtualization provider and the headset. And as you can see, it's a seamless transition from the browser into the immersive CloudXR experience. In this case, this is the VR template from Unreal 5. And as you can see, just moving around through the scene, CloudXR is doing what it's meant to do. Very fluid experience. In this case, the headset is in Calgary, and the instance here is running in Chicago in the CoreWeave virtualization provider. And yeah, and that's a quick demo of how our system is set up.
I'll just remind everybody, if you have any questions about what you've seen in the video or really anything in the presentation so far, please drop those questions into chat. And Kevin and I are here, and we're happy to answer those questions as we go. So let's now dive into the actual architecture of the platform and how we achieved what we saw in the demo. And I'm going to look at the architecture through the lens of what Kevin just talked us through, so that we can sort of map the architecture back to the things you saw in the demo. So within the PureWeb platform, we tend to partition along an architectural boundary that you probably heard Kevin refer to in the video as a virtualization provider. In this diagram, there's sort of two key pieces. The left-hand piece is what we refer to as our core platform. And this is a platform that handles things like our identity authentication so that you get the appropriate access tokens, so only the right people can access the right streaming experiences. This is where our global routing system lives. This is where that single source of truth that Kevin mentioned exists in the platform. And then it's where all of our signaling and matchmaking services exist as well, so that we can connect the right client device to the right streaming endpoint. On the right-hand side of the diagram, we have what we refer to as our virtualization providers. And a virtualization provider is basically just a place in the world that has some capacity to run some sort of streaming application. We have currently three flavors of virtualization provider. We have what we refer to as a dedicated provider that runs in AWS. This is for users who want to have a sort of a completely bespoke infrastructure experience that we're able to set up for them that is defined to their exacting specifications. And then we have two flavors of what we refer to as on-demand virtualization providers. And these are providers that are able to pull on our shared pool of servers to basically pull a server out of that pool to provide a streaming source for whatever application you may have at that moment. The platform and the virtualization providers speak to each other over a binary protobuf protocol. And this is very key for us because it allows us to basically create a contract between what a virtualization provider is able to do and how that communication channel is honored between the platform and a virtualization provider. So if we think back to the video or the demo that we just saw with Kevin, he had an Unreal application that he uploaded to the platform. In that case, the application would have gone into our primary storage system. And at that point, the platform is going to send out a notification to a number of different virtualization providers. I said before, we have 3 flavors, but in terms of the actual number of instances, we have actually dozens of instances of virtualization providers running around the world. And that's how we achieve that global reach. So a number of these virtualization providers are going to get a notification that there's a new application that they should be provisioning into their environment. So the message is going to send over the protobuf. In this case, in the demo, that message was first received by the CoreWeave provider, and the application was provisioned into that environment. Then when Kevin went to go actually launch the application from the client device, in this case, it's a head-mounted display, but for flat streaming, this could also be a browser. So they're going to make what we refer to as a launch request. So we're going to say, I would like to launch this particular streaming application. That request is going to come into the platform. And then the global routing system is going to kick into action. It's going to look at everything that it knows about all the virtualization providers in the world. It's going to know which applications are able to run in which providers, what the current utilization of those providers are, and if anybody is maybe queued up for a particular experience, if, for example, a provider is particularly overloaded. It's also going to take into account the network location of the client device so it can position you optimally. And so it's going to take all of that and sort of put it into the hopper and figure out where is the absolute best place to send you to have the best streaming experience. And best for us basically means you wait the shortest amount of time and you have the best interactive latencies. That is to say, we reduce the network latency as much as possible by putting you as close as possible to the end server. So in that case, he was routed into the shared CoreWeave server that was in Chicago, into the shared CoreWeave provider. And then from there, he was routed onto a particular server. At that point, the application is going to start up. And through our signaling and matchmaking services, a peer-to-peer connection is going to be brokered between the headset and an actual server running within that virtualization provider's cluster. So that's how this looks at sort of a global scale. Next, we're going to zoom in and see what this looks like at a more regional level. So this is similar to the diagram we had before, but we've abstracted away a lot of the pieces that we don't need at this scale within the platform. So the platform is on the left-hand side here. We still care about this concept of virtualization provider state and this concept of signaling and matchmaking. And then we've zoomed in on that CoreWeave regional provider so that we can get a better look at what's going on under the hood. So within the provider itself, there is a virtualization provider microservice. This is something that we've built that, as I said before, adheres to this contract about how it can communicate back and forth with the platform. And it's going to receive information from the platform about which applications it should be capable of running at any given time. This is based on what's being uploaded to a console. And it's going to send back information at a very regular cadence about what its current utilization levels are, what applications it currently has provisioned, and what's currently available in its environment. Within a provider, we also have local block storage. Kevin referred to this idea of a single source of truth that exists in the platform. And that's great for having your sort of sense of canonical storage. But when you care about really rapidly provisioning onto a local regional server, you want to have storage that's as close to that server as possible. Because you could imagine, for example, if your single source of truth was in the Western United States and you wanted to provision in a just-in-time fashion to, say, Central Europe, that would incur a very significant performance burden as you copy this multi-gigabyte file across the world. So we do that in advance so that when we're turning on infrastructure behind the scenes, we can rapidly provision them from a local storage. Additionally, every provider has some form of local state. In the CoreWeave provider, we have used Redis, and this just basically stores information about what applications are running on what servers at this point in time, and the virtualization provider uses that to then inform the platform back about utilization levels. And then lastly, we need to build an autoscaler. So within this cluster, there's an autoscaling mechanism that we built from scratch. Um, Traditional autoscaling mechanisms tend to be based on more stateless workloads. So, what is your CPU utilization? What is your GPU utilization? These are not relevant in a 3D streaming environment where you don't actually care about those things as much as you care about how many servers have streaming sessions on them at any given point in time. And those streaming sessions are stateful. So we've essentially built a stateful autoscaler to handle that. If we zoom in even further then into an actual virtualized instance, you see three particular components. You're going to have the Unreal Engine or the Unity Engine game that you've built and uploaded, or native Cloud XR application. And then you're going to need a service that actually starts or stops that application. So we have a game lifecycle service that in response to signals will say, I need to now start this application so that it can start streaming. And then when the stream is completed, it terminates that application and cleans up after itself. So when the game is started, it doesn't actually talk to the browser or to the headset directly. We need to put a proxy in front of it, and that proxy knows about our signaling and matchmaking services. So we call this a streaming agent. And so essentially what happens is when your Unreal application starts up, your Unity application starts up, it's going to talk to the streaming agent, and the streaming agent is going to talk back to our signaling and matchmaking services in the core platform, and it's going to know where the client device is in the world, and it's going to broker that final peer-to-peer connection between the virtualized instance and the headset device, wherever it is out in the world. And at that point, you're off to the races and you're streaming. So this is the architecture in the small. What you're going to find is that one of the major benefits of this is that virtualization providers are fully self-contained, and that makes it really easy to replicate. So if we want to put more virtualization providers in different regions and different localities based on load in the world, that's very easy to do. Additionally, the platform doesn't care at all about how a given virtualization provider is implemented under the hood. We looked at the CoreWeave provider, but you may recall in earlier slides, there's two other flavors of provider, and I can tell you, they are radically different in their implementation. So this, as long as they're adhering to that protobuf contract and sort of sending the right messages back to the platform, the underlying implementation is sort of an implementation detail that the platform simply doesn't care about. What this means is that they have different mandates. A virtualization provider is focused on local optimization. It only knows about what's going on in its cluster of servers within its region. So its job is to maximize utilization and minimize wait time. And the tools that it has to do that are scheduling operations and scaling operations. Meanwhile, the platform is responsible for global optimization. So the platform's job is to minimize latency and minimize wait time. And it can do this by routing. And so this is where the platform is getting signals from all the virtualization providers, and it's making decisions about how it can best route load around the world to achieve its goals of minimize wait time, minimize latency. Now, the really important detail here is that all of the architecture that we just saw, there's nothing about that that is intrinsically WebRTC based. There's nothing about it that says it must run this particular protocol. It's fundamentally protocol agnostic, which means that when we took the platform, which was initially built for flat streaming, we got out of the box the ability to upload, provision, route, schedule, and scale for Cloud XR without any additional work. Because again, we didn't really care what the protocol was on top of this. So that's not to say that there weren't some challenges. There are definitely some rough edges as Cloud XR is on its maturity journey. And Kevin, I think you'd be able to talk best about what's going to be sort of what those challenges were that you experienced in doing this work.
Thanks, Chris. Yeah. I mean, as Chris said, I mean, the platform is fundamentally protocol agnostic, but a lot of that is dependent on the idea that the workloads are self-contained. And one of the biggest challenges that we faced with Cloud XR in its current incarnation today is that it really wasn't or isn't in its current state developed for scalability. I mean, they've taken great pains up in the journey of CloudXR so far today to assess its feasibility, making it work great in the small, and understanding what it's capable of doing. But as it's built today, it operates as a Steam VR plugin, and that imparts upon the solution a number of workstation-based dependencies that aren't insurmountable, but do pose challenges to taking this to scale. Two points around that. One, in terms of those workstation-based assumptions, those manual steps that are required to set up CloudXR today, is that it's not easy to automate. Certain installation procedures, certain steps along the way just require additional work and workarounds to get working. It also lacks the ability to observe in a convenient programmatic way what is going on in terms of is the headset connected, is it disconnected, has the game started. Those types of events are important to drive the total experience in terms of making a connection from a client device to the headset in a seamless, automatic way. Another set of challenges that we have are something that we refer to as headset SDK sprawl. It really is the situation where when we are flat streaming, we've got the browser as a common unified client abstraction. We can leverage the web APIs to build out experiences that work on any number of browsers the same way. It's one development environment for client developers to worry about, and that is a great position to be in. When it comes to streaming VR and in general headsets, there isn't a unifying abstraction, which makes developing clients on these headsets really an unsustainable endeavor. The maintenance involved and the number of permutations of features that you'd have to recreate in all these environments is just something that isn't appealing, and something that we definitely not want to endeavor to do forever. And that kind of takes us into where we want to be in the future. If we look at next steps, PureWeb and NVIDIA are both committed to the idea of taking CloudXR to a mass scale, taking CloudXR as a streaming technology and really having it reach the potential of a globally scalable solution. With CloudXR 4, we know that the focus is going to actually be addressing these scalability concerns, focusing on more self-contained deployment models where those fit even better with what Chris was describing in terms of the workloads that we see on the PureWeb platform. The reduction of dependencies in general and being able to essentially move these workloads around really will create an environment that lets us scale out into the future. There are a few other interesting talks around CloudXR at GTC this year. One where the CloudXR team, Will and Arjun, are going to be talking about next-gen XR streaming. That's the CloudXR 4 introduction. And another is queued up as well, a session that is around building CloudXR applications quickly with Unity, which hopes to address that SDK sprawl that I just mentioned. So with that, Chris and I just want to thank you all for coming. We'll go into some Q&A now. Chris, do you want to say anything?
Yeah, I just say that if you want to learn more about anything that you've heard today, there's some links on the screen there. You can head over to our website. We've also got our developer hub there as well. And then if you're really curious and want to get into the weeds, you can see some of the stuff we've built on NPM. And if you want to reach out to Kevin and myself directly, our email addresses are there on screen. And if you just want to reach out to the company generally to make inquiries about this technology and the solution we're building, the info contact email is there as well. But yeah, I think that's everything from us. I want to thank you all for watching our talk, and we hope you have a fantastic GTC. Thanks very much.
Thanks, everyone.